Um, the next topic, let's see. Well, I was just going to say combinatorial explosion here in the context of, so there's a combinatorial explosion in the context of these parameters, and Gerhardt was inquiring about that. So as the number of parameters you want to vary in sensitivity analysis simultaneously rise, it's fine to examine one on one, but if you want to examine them all simultaneously, you want to examine, for example, all four with respect to this particular experiment, you're going to be getting into an area where you have greater and greater load. You deal with what's called a cursive dimensionality. The number of combinations rises rapidly. So if you have just one parameter, 10 values, you have 10 possible combinations. You have two parameters, 10 values, you have 100. Three parameters, 10 values, 1,000. Four parameters, 10 values, 10,000. And each of those you may want to run 10 times or a couple dozen times. And you get into a combinatorial explosion. So I mentioned here some alternatives. One was dimensional analysis. I mentioned Monte Carlo techniques are often used to blunt this by drawing values from distributions. And here's where I mentioned orthogonal arrays and Latin hypercubes. Latin hypercubes allow you to have at least one representative value of each parameter for each possible value it can take on, a range of values it can take on. So you're guaranteed to have some representation when, say, for example, the average illustration is at its highest value, some value when it's at its lowest value, some value when it's all the way in between. And same thing with infection probability, but you're not guaranteed to have all possible combinations of those. You just make sure you hit each possible value for each parameter in some combination. Similarly, for orthogonal arrays, you have all guaranteed pairs of values. And as Scott emphasized earlier, there are automated softwares which will basically automatically spit out for you combinations of values that work. And you could then impose those values on the parameters. How would you do that? Well, without going into an actual example, one thing you could do is do here in Monte Carlo 2D histogram, we could impose a free form here. And you'll notice this expression is something we can set, okay? You'll notice also there's a hint. And this is the key hint to look at. You'll notice that up here to the upper left, there's this thing that says use index to mean the iteration number. In other words, which iteration are you executing? Is this the first one, the second one, the third one? And we could use that index to look this thing up in a database, or we could draw it in from some array. So we could have something like average illness duration experiment array, of index. And what that would do is it would look it up in some array, get the value from that array, and that array might have values that were set, or you could have get index depending on what sort of data structure it is. And that sort of array would basically store the different values to use for average illness duration, each successive iteration. That array might be output by Mathematica or some other package that allows you to derive these values in turn. Okay. Same thing with the infection probability. I could draw that from an array. Alternatively, I could even look it up in a database. I could say my database dot get illness duration, and maybe this would actually be a function that I define, and it looks it up in the database and gives me back the information. So the point is we can draw these values from distributions. Draw these values from all different sources. We could also draw it from distributions. So for example, we could draw this from a log normal distribution or some other source. I thought I had an example of that here, but I could draw, if I wanted to do this experiment in Monte Carlo way. Remember, folks, always you should reflexively challenge your assumptions about any logic. You might think by looking at these things have to be constant. They are not generally constant. You could use them as constant for the stochastic experiment we did earlier, but you could draw this average illness duration from a beta distribution with some values for the beta distribution. Unfortunately, it doesn't allow autocomplete there. So maybe we could send that home, Scott, to the mothership. But we could draw this from a beta distribution with some parameters. I don't know what extra parameters it supports there, but it seems to be happy with that. So here, folks, I'm running this thing in a free-form way. I'm drawing average illness duration. I'm not using it in a grid. Instead, I'm drawing its value each successive iteration from a beta distribution, and it looks like it's a singularly boring thing, probably because that's too short to sustain infection. Maybe I should raise its value significantly, and let's see, it was between 5 and 15, I think, before. So here we could draw things from beta distribution. Okay, it's still not good, but in any case, it's drawing it from a beta distribution there. In general, we could look it up. We could look it up in a table. Okay, so this is a very flexible way to draw values from any number of different data sources. Generally, if you have to examine variation with respect to a large number of different values, doing so through more judicious choices, like orthogonal arrays or Latin hypercubes or some more advanced technique, is quite advisable. Okay, right, question. Yes. Oh, sorry.
So just some practical considerations.
Yeah.
For doing a sensitivity analysis, if you identify the parameters or anything that you want to perform the sensitivity analysis on, 10 to 12 runs or iterations on that is sufficient?
So if you identify, you're saying if you have identified the parameters, how many real replications do you need to run?
Yeah.
No. So the number of replications that you'll want to run is really guided by the level of statistical confidence that you need to secure. So it's really a power issue, a statistical power issue, and you're going to presumably have certain model outputs that you're interested in reporting or sharing with other people. And if you're interested, say, in comparing interventions, there's going to be if you run a report, say for your model associated with chronic for Jones disease, you might report, something on the order of incident case count or something like number of positive tests, or maybe it's something having to do with costing. You might want to report that as part of your analysis, that this intervention versus the baseline, for example. And there, you're going to want to use certain type of non-parametric tests because you don't know the distributions of those. You can't say with confidence that they're really well approximated by normal distribution. You could do a QQ plot and so on to try to look at how well they're approximated, but in general, there's a set of good non-parametric tests that can be used on a pairwise basis, like Kolmogorov-Smirnov test, or like the Mann-Whitney-U test in its one-way form or two-way form, and then a sort of multi-way, like the Kruskal-Wallis test, which I think Charles had mentioned as well a few days ago. And these tests could be used to sort of compare a realization, an output from a given intervention, say, with output from the baseline, with respect to the quantities of interest. And to achieve a certain level of power in that test, you may be able to do the calculation sort of, up front, sort of what level of runs you might estimate that you needed based on preliminary results of the differences. Or you might want to do it and see if the number of runs you've done is sufficient to lend you that level of statistical significance that you're seeking, say at 5% level, and if not, you can do additional runs and sort of fill those in, and that would be sufficient to then lend confidence that you're seeing real differences between say multiple interventions or an intervention in the baseline. That's how I would approach it. I'd welcome other people here, so Scott or Cheryl to comment on that as well.
I mean, I think, I guess I'm seeing the Monte Carlo simulation sensitivity analysis is two separate things.
Yeah.
And my question is that actually merged?
Oh, I
Because-
see.
So I have, 6 or 7 scenarios on Monte Carlo.
Sure.
And I want to know if those scenarios are sensitive to different changes. I also want to know if the output I get is sensitive to some of the model assumptions I made.
Indeed.
So when you're talking like,
Yeah.
7 scenarios, 100 replications of the model, and then you're on top of that, you're varying all these things to try to understand what the model is sensitive to.
Right.
And I guess my question is more about
How do those?
how do you approach that? How do you put it out? How do you
Yeah.
deal with that?
Yeah.
Because it's just getting exponentially large, the number of replications and
Indeed.
things that you do.
So I think that's a great question, and I don't view my comments on as particularly privileged, so I can invite comments from others, but personally I would distinguish between, like the process I was just talking about, I misread your question, I apologize, as sort of having to do more with how many replications do I have to run, like when I'm preparing to report my results, and that's a different question. What I think you're talking about is more the exploratory side and kind of trying to figure out robustness, say, of your results to assumptions as found in sensitivity analysis, and the ways in which that interacts with this other issue of statistical confidence. So one thing, I'll throw out some things that we do, bearing in mind that this is not terribly, privileged, and I don't think it's sort of the only way to do it. So, in one modeling project, we actually had a sort of a systematic examination of a set of different parameter values, and we identified those exhibiting above a certain level of variability. And for those, we examined multi-way sensitivity analysis, look at interactions between them. And then we examined, for this case, I'm not sure if we made that next step, but for each intervention, one could, in principle, look at could summarize sort of for the interventions, varying the parameters that were identified as being most sensitive. To what degree does that change the ordering of interventions? And there's a methodology whose name I'm blanking on it right now, but it was actually used by Yvonne, who spoke this morning, to summarize exactly that. So the idea is that you have these maybe 7 interventions, and you would vary the parameters, and you could see, what fraction of time, say, this particular intervention stayed the topmost, which, what fraction of time this next one was in the topmost position versus other positions. That was a more extensive examination. In many Asian-based models that I've seen, what you instead do is you take the model, you perform sensitivity analysis, often on a one-way basis with respect to a set of parameters, and you report sort of different levels of sensitivity on a one replication basis each, and then you would go and examine, with respect to the baseline assumptions, the ordering of sort of interventions in terms of gain, and that's it. Okay, so I mean that's done. I'm not sure that's that's desirable, but that's kind of, I would say, the bare minimum you could do. That's the bare minimum, but it is done quite a bit. Now, as far as how many replications to use, certainly for the baseline experiment with interventions, I would be sure to do it to achieve that level of statistical significance we talked about earlier. But going this extra distance of asking to what degree the varying, the sensitivity analysis changes the ordering of intervention results. There is a methodology for doing this. It's been formalized, straightforward, and there's in fact tools to help with it that UN could refer you to, etc. But it is, I have seen that, I don't think I've seen that in a single paper in the ABM space being used, and it's kind of unusual even in like system dynamics space or anything like that. So that's those would be some comments. But Cheryl, you probably have some thoughts on this.
Sensitivity analysis. I think the view you're talking about is perhaps really well applied also with respect to testing and interventions. Sensitivity analysis is usually done based on and then individual intervention and ability also tests the interventions. But just question two things about making this having this sensitivity analysis on the intervention analysis. You know, we do the sensitivity analysis for each intervention. And you don't use
No, it is, again, it's something we did do with respect to one project, because we were particularly interested in this question of how did sensitivity analysis change the order of interventions? Which intervention was looked at as most desirable? And again, there is a methodology for doing that, but I haven't seen it, in any agent-based models. But one thing I would recommend, Carmel, is I talked about the bare minimum where you're just doing one-way sensitivity analyses, and the sort of other extreme where you're doing multi-way and looking at interaction with intervention ordering. That's something that within is goes well above and beyond sort of in the ABM space. But an intermediate thing is you do one way and sort of in a methodology somewhat representative stepwise creation of statistical models. You do the one way, you again capture those that exhibit more than a certain level, and then you do a multi-way just for those on the baseline. Based on the outcomes from the moment. And I think that would be regarded as very, very good. Very good. It is hard to publish a paper these days with a simulation model where you've not done some sort of sensitivity analysis. If you bear that in mind. It's like one of the things that review will say, like, it's a sort of formula. Where's the sensitivity analysis? Go back to the future. And so then you do a less. Yeah, but it's better to do it up front. Better to do it.
what's the standard for reporting that subsequently is okay, within statistical analysis right now, that's not
Sure.
and all that, but the number of people who actually report the results of, they say they did it and then peachy, or they say they did it in an outlier and they got it this way, but they don't actually give you visuals of that.
So sometimes you will see visuals in the form of like a spider diagram for multi-way. So the idea is that you have really what you call a Vagar diagram, what have you. So you have sort of several axes, one for a set of different parameters. A good one. But maybe you have 5 parameters, something like that. So your parameter A, parameter B, parameter C, parameter D, parameter E. And what's shown here is kind of marks as to when you varied each of these parameters by some proportional amount, maybe it's by 1% or 10%, what was sort of the level of impact on sort of the the variability model, some particular model output. And so the idea is like this one, varying it by 10% led to a big change in the model, whereas, this one it was comparatively smaller, and maybe I'll just for didactics, I'll sort of highlight this, and this one it was much smaller, that elicited difference in model baseline output with respect to some particular model output. Yeah, sure. No. Yeah. So, diagram showing sort of, and what you have here is the different variables. Yeah. Good. So what we're seeing here with respect to performing these things in these models, we're highlighting in this discussion, which I really love. These are exactly the sort of things I was hoping this boot camp could bring up, is these things where we can uniquely discuss them rather than just formulate a presentation. But what we see here is a situation where I think any logic, as a tool, it makes the basic mechanics of the analysis straightforward enough that the real questions are, conceptually, what's the most rigorous way to proceed, or what's the best way to proceed in terms of credibility and publication, et cetera? What's the appropriate theory behind it? Actually, performing it with any logic is not terribly hard. And if any of you are struggling with, you want to have this thing to look up the values, you can import them from an array, just let me know. We'll pump out a model like that. It'd be really, really straightforward. So the mechanics here with any logic is not the hard thing. The hard thing is like conceptually, what are the steps you want to undertake for your model to secure the appropriate level of credibility and level of rigor in terms of the results. So I welcome this discussion. It'd be nice to see if we could continue to contribute as a group to help people share experiences and share suggestions. I'll see if I can get that reference to the technique UN has used. This is work with Kristen Haskell with UNC on sort of the sensitivity with respect to model results. Okay. So any other sort of questions or comments with respect to sensitivity right now? No? Okay. Well, I think we are going to proceed now to lunch, where we'll have once again two if Scott's okay with serving in the second talk. That would be great.